All right, where were we? On Wednesday, we looked at the strategy pattern and applied it to the game. Started getting some really fun behaviors worked in. Let's see where we want to start refactoring. Alright, and the code from there is on GitHub, and that kind of represents the break from one pattern to the next. So if you went into the MudZ game, there are milestones. For phase 1, we want to implement the factory pattern for creational stuff, the strategy pattern for all things behavioral, and the bridge pattern, which will be week 3. So, as a goal for today, I want to try to clean up as much of the strategy pattern and the game as a whole to make sure that the things that I do behind the scenes aren't a surprise the next time we stream, people see the code. Don't want that culture shock of people come in Tuesday and all of the game mechanics are different, all the code's different, and it's very much a cooking show where it's, ingredients and then magic, commercial, bam, full dinner. All right, let's put this there. So to keep the game more in line with the strategy patterns we want to introduce, I simplified the plan, and I'll show what I mean by that here in just a second. So previously we had damage being done, people being healed. You had this kind of round. So you had like a round, like a fight would have rounds, and there'd be an interplay, things that could happen during that round. Someone could get healed, you could break away from the fight entirely and run away. And I'm backing off of that concept a little bit because it would involve, for the game engine, a lot of event-based programming. And while that's fine, essentially we'd get to, let's just say, arbitrarily, week 12, and we'd have this complete game we could play. But we'd then fall off a cliff in terms of the game engine because we'd have to dig so deep into event-based programming. We'd probably have to bring in some extensions like reactive to handle all of the concurrency of events and the quality assurance to make sure when multiple players were doing things that they were replayed in the same in the correct order in terms of lag. So, not that we won't do it, but we just won't start with that in mind. What we'll do instead is we'll get through quite a bit in terms of design patterns and code, and then once we get to the phase 3, we'll decide, okay, now that we have this thing that really works, and which one of these patterns is going to create the best game experience and also the best learning experience for us. There's kind of concept of like in the weeds with this, where if you get a really complicated game engine, you could be in there for months just tweaking and changing and sketching out rules and all that fun stuff. All right, let's get back to this. So, change the game up so that instead of this concept of event-based rounds and interrupts and things like that, essentially you'll have an environment that you'll start in, and you'll create your character, and you'll have, we're going to call this stamina, in terms of turns. So you're going to have a certain number of turns, and then depending on your class, you're going to have, let's go ahead and write this down. Depending on your class, different things will take up a different amount of turns. So now would be a great time in refactoring to go ahead and write some of this out. What's the game idea or game brainstorming? So, turn-based. Turns will be called stamina and depend on your level and class or level and attributes. Actions: fight, repair, heal, negotiate. Alright, I think that was it. Let's go back over into our player. Repair and negotiate were the two things that differentiate a player from just a standard actor. And an actor can be a monster as well. So everything can fight, everything can heal, i.e. monsters can fight, and monsters can heal themselves. And then players, in addition to that, are going to be able to repair and negotiate. Okay. Let's call this players. Let's call this world. Laws. Okay. The 24-hour, well, let's say every day. Okay, so every 24 hours a series of problems will spawn in town. What this calls the cycle, the game cycle. Every 24 hours a series of problems in town. So these problems will require that you either, like, so a zombie appears or a monster appears, you have to fight it. Something attacks the walls of the town, you have to repair the walls. Someone gets hurt, you have to heal them. An argument breaks out amongst townspeople, and you have to negotiate. So, game goals: to keep as many towns, people alive as possible. To stay alive. What's really going to be it? Okay, and game stacking. So, anything you don't solve within 24 hours will worsen and be added to, let's go ahead and be added to the next day's problems. All right, so the concept for that's going to be you wake up fully rested with all your stamina, and there's a zombie in town. They got through a hole in the wall. They attack somebody, and there's an argument going on. So you can decide what to do in terms of resolving that. The trick is going to be the use of your class and your stamina, and depending on the difficulty level will determine how easy or hard solving all of the problems in one stretch is going to be. So I would fight a zombie, and if I'm an army vet and I'm more effective at fighting, that's going to require less stamina. If a zombie attacks somebody, I need to heal them, and I'm an army vet, well, that's going to require more stamina than if I was a medic. And then if I don't heal that person and the 24 hours passes, they die, and I'm down one townsperson, right? If I kill the zombie but I don't repair the hole in the wall, then the next night there are going to be 2 zombies. Or the next day there are going to be 2 zombies, and maybe they've attacked more people. So negotiation will probably be the politician is almost like a wizard class in that sense. Like, you don't really see the value at first, but it's actually really powerful. So ideally, at the end of every 24 hours, the game engine will simply make a bunch of decisions, like there were no arguments in town, so the townspeople were able to get together and kill the zombie for you. So when you wake up, you get this kind of news report saying, hey, a zombie came in, but the townspeople handled it. All you have to do now is repair the hole in the wall, heal this person, and negotiate. Alright, so that's going to be our basic game brainstorming. I'm going to write this up in a kind of more formal document and put it out there, so that hopefully, if people are interested, they can kind of help, as I see the game evolve, kind of help with these rules and what should happen. But I just want to get that out there now that we're kind of seeing things happen. Okay, so for our strategy pattern now, we've got these 4 actions: fight, repair, heal, negotiate, and we want to implement a bit of behavior for each one of our player classes. Alright, so instead of a player, when a player calls fight, it's going to run the strategy attack. And we're passing in the player itself so that the strategy can act upon it. And what that means is, for the army vet, let's just say that when he attacks, he returns 20. But we also want to reduce the player stamina equals player dot stamina minus 1. So we're already seeing, and again, before we had said it's kind of important to look at this as being an algorithm. Just returning that double of 10 is the most straightforward and simplest algorithm you can write, which is good because now we're getting into 2 things happening, and the calculations for how much stamina are removed for the army vet when he attacks is very straightforward, but it could also be based off of some combination of 1/10 their level plus 2/10 their strength plus whatever, and that algorithm can change greatly per class. And this is where the strategy pattern really shines, is that we can encapsulate what could be some very complicated algorithms and very different algorithms and swap them out on the fly as we need them. Alright, so we're just going to say, keep it simple. And let's go ahead, since we're going to be writing this a few times, we could copy this here and here and here and all throughout. So it's a question you really have to ask yourself in terms of the game mechanics. If this algorithm for removing stamina, I'm sorry, not this algorithm, because the math could be different, but if this operation is going to be the same, then we really want to create something like this. We're say private adjust stamina, and we'll take in this case just an int. I'll just call this adjustment. I'm also taking the iPlayer. We'll say that player.stamina equals player.stamina minus adjustment. And then we want to call adjust stamina. Oops, that's that, and that. We're going to double? No, but we're making that a negative, so it's going to say 1. We'll pass in the player. Alright, so we're doing this here. We're saying when the army vet attacks, their stamina is reduced by 1, and they return 20. When they heal, we'll just say their stamina is reduced by 3. So I'm inspecting here, but I believe I pulled that out, so that's, if I haven't, looking at something shouldn't cost you stamina. Look all you want, but repairing should. Just go ahead and copy and paste this. Remember, we're repairing game objects because we allowed for every game object to be destructible if we want to take damage and also be able to be healed. So or restore damage, or restore health, I'm sorry. So every game object can either have their health restored or take damage. So we don't want these to be voids anymore. Let's go ahead and fix that. So we're doing this more of kind of a role, kind of a B&D kind of idea, where you're presented with a problem like, hey, there's a wall with, I don't know, total hit points of 40. It's taken 15 points of damage. Go ahead and do your repair roll. So let's go ahead and do your repair roll and see what happens. And depending on your class, you'll get some plus to that roll and repair the wall. Pretty simple. There's also, for example, to be an argument going on, and you roll to negotiate and see how effective you are in reducing that conflict. Attacking and healing are pretty much the same thing. Same concept. Alright, let's go back in here. We change those signatures to being doubles now. And double. Okay, I'm going to leave this as a base 10 for everything else for right now, while we talk about the concept of taking damage and restoring health. Let's just say that this is pretty straightforward. And real quick, we've got the player, which comes from the base actor. Which is an abstract class. And we didn't give it any kind of base functionality, so that's fine. So the question we have to ask now is, we've got hit points, but are hit points the same thing as health? No, so just organize this a little bit better. We're going to use C# regions to kind of get our head around these. Let's say actor stats. Put a region about this. Now, coding people will argue against the use of regions all day long. I think when you're dealing with abstractions, when you're dealing with the behind-the-scenes stuff, they're crucial. When you're dealing with the calling layer, I think the architecture that you've designed should create such a simple interface that regions become a silly thing to do. But behind the scenes, yeah, I use them a lot. Default actions. What do we call this? What is stamina? There, it's called game engine. So yeah, then based on what we said before, stamina is going to be your turns. So put that. So anything that's about the base actor that really integrates with the game engine directly, like your turn system, we'll put in this region. Default actions will be here up top, and then actor stats being, so actor stats or statistics will be things that can influence the algorithms. So your healing algorithm could be dependent on intellect and wisdom or willpower or charm. Your attack could be based off of endurance and strength plus level and some equation using all those things. We'll leave that to the side for right now and get to keep our algorithms as simple as possible. All right. Jump around a bit. Equals player dot hit points plus health. Hit points has no setter. Good point. Let's fix that. Because it really wants us to use the restore health. Man, old us is smarter than current us. So, let's say that var health, we bring in health, but we might want to apply it to some sort of algorithm. So for right now, it's health equals health. But it could be health equals health times health divided by player. Well, let's change it so it's less confusing. Change that to hit points. Is it less confusing? Healing? Might be better. Alright, let's go ahead and jump around a little bit. Alright, let's have no setter. Let's give it a setter. Alright, and this, so for the Army vet, this could be our algorithm. It might not make any sense, but it could be you receive in an amount to heal, and the Army vet, for whatever reason, applies an algorithm to that and then applies it to the hit points. But we're going to make that really simple for right now and just say this happens. And same thing here, we could have an algorithm where it was that damage has to be reduced by the person's strength and dexterity, and then also maybe some sort of special reduction for the class. But we're going to allow ourselves to change these algorithms depending on that class, which is the whole point of the strategy pattern. And if you remember, inside of our non-player characters, inside of NPCs, we do have a factory pattern. We have non-employed the strategy pattern, and inside of NPC, we just give the default behavior. So this is the difference between our base class NPC abstraction and without a strategy pattern, where the behavior is just inherited by all the NPC types, versus our strategy pattern, where we've abstracted out that behavior into our various classes and call them strategies. Okay, so we haven't really made use of our stats. We did add a set stats method so that the classes could vary a little bit. So an Army vet might be stronger and have higher endurance than the politician, for example. We saw those here, so that we have those values to take advantage of when we want to make our algorithms a little more detailed. But right now, if you attack with an Army vet, you'll have one stamina reduced, or your stamina will be reduced by 1, and you return 20. Okay, and so to compare that against when we haven't done yet, to see how much work we actually did, if I go into the carpenter, let's go ahead and fix this up. Let's close this, close this, close that, that. and that, and this. Let's just get the player up here, the strategy, and then all the ones we're working with. So carpenter, army, vet, politician, medic, and mechanic. Okay. So we like this. We're going to reuse it. The one shortcoming of the strategy pattern is when we look at structuring and trying to use some OOP. So you can have a base strategy, and we could throw that here that takes care of some of our cross-cutting concerns. Or, and we'll see this next week, we could use the builder pattern, which allows us to, it's a structural pattern, which is going to allow us to overcome this deficiency of the behavioral pattern where, man, okay, I got these strategies, but what happens when I want to branch out to lower levels? What happens when I want to add complexity on the fly? What happens when I want to start composing things with a little more complexity? The structural patterns, that's when they come in. But right now we're just going to do it lazily, and we're going to break some rules by reusing our code. So ideally, if this was going to be the same between every single class, we wouldn't want to see it in every single class. We want to see it in a base type that allows these classes to inherit that functionality. Much the same way that the NPCs have a base way of taking damage and restoring health. I'm not doing that now because I want to save it for the builder pattern so that we can see how these abstractions start to layer. I'll talk about that just a little bit. So somebody had asked before why we used an interface here versus like an abstract type. And this is the reason. We're saying that this is going to be the implementation. This is an abstraction. So we abstracted the concept of player into this class, and we've said that a player is composed of a base actor, a strategy, a player type, and all these other things. And then we've said the strategy is going to be an implementation. We could say that while player is an abstraction and a composite, that we also want action strategy to be an abstraction, which means that we don't care about calling it here. We'll defer that responsibility later on down the line. So the builder pattern adds to our ability to structure our code, but it's actually, without really digging into the code and understanding the concept, to do it now without the understanding would just be really confusing. Paradise says my stream is buffering a lot. I don't know what that could be. Last time we streamed, there was some problems on Twitch's end. I'm content to think it's also them. I'm hard-lined to a pretty nice fiber connection, so fingers crossed it's not that. Okay, so not to get too far down the rabbit hole of structuring this stuff out, but just wanted to show that yes, we are copying and pasting the same thing over and over again, mainly because it's a problem we don't know how to solve yet, but we will next week. Refactor up some more stuff. Okay. So, just to keep in our mind what we did with the Army vets. So, instead of returning, we'd return 4 for their attack, and we'll say that the politician takes 3 stamina to attack. I still like the idea of the politician doing more harm than good when they try to heal. So for the stamina, we'll say 3 again. Politician is just not very good at doing any of this stuff. Man, 3 again. And when they negotiate, they take 1 and they return back 20. Alright, so super simple algorithms here. Not doing anything crazy. And we're going to be using the same algorithms for take damage and restore health, just keep things simple. And we're not refactoring those out into a base class, not just because we've got the builder pattern coming, which is going to help with that, but also because we do, even if we didn't know the builder pattern, we do plan on having this variance per class for all of these methods. So in this case, pre-optimizing, because we know what our plan is going to be, pre-optimizing here and refactoring would be an anti-pattern, right? It'd be something we'd have to redo later on anyway, and we'd be fighting ourselves. So we're going to leave that in, even though by the strictest of principles it does feel wrong. We know this is all going to vary quite a bit, even though it looks the same now. And at some point in your career, you're going to have that argument with somebody where you're like, hey, we've designed it this way because we know it's going to change or grow and expand. The redundancy is an illusion right now. So, little mind trick, the redundancy is an illusion. Okay, so save ourselves some time here. Because this hour goes so fast. I'm just going to copy and paste the things we know are going to be pretty much the same. Make those at a double to satisfy the contract. Okay. And with a mechanic attack, we're going to do a just stamina, pass the player and make that 2. And return 7. Pretty arbitrary numbers. And we probably won't just have a reason to change these until we come back and look at how the game interaction occurs. Mechanic is not very good at healing. We've removed inspect. You know what? Make that 2 and just return 10. Mechanic's a good old boy. He could probably talk some people off the ledge if he had to. Okay, so things are shaping up. When you see this as a coding style, The this is almost as good as your to-do, right? Stuff. And so you'll see how that gets highlighted. I don't even know if that's ReSharper doing that. It probably is. But some people in their coding style, they love to throw this to-do comment around, and then as their point of refactoring, and then they'll go through and they'll do a control find across the entire solution and say, okay, let me go through and remove all my to-dos. I guess it's fine if you do that. Please don't. Please don't. My humble recommendation is to throw these not implemented exceptions anywhere that's the case. This early on, and train your eye to, when you see that, to pump the brakes. Right? It's a part of practicing and creating these katas. At a glance, when you're looking at this class, you should immediately know when you see this, okay, something needs to be done there. Not implement exception is not what we want to see as the only line of the method. Let's refactor that. And then you can control F and you can find on not implemented exceptions. Or if you want to add a little bit more info, throw your to-do there, so that when this gets thrown by the client later on, you get this to-do. And there's famous stories and screenshots out there of, there you had one job where a production game gets out there and there's just a to-do, right, as the output, or a reminder that instead of a texture, there's just a little bit of like a text GIF or GIF. So, but this is going to be better practice for most cases. Okay. A medic, not really good at attacking. Yeah, it's fine. Maybe they attack with their medical shears. Heal for 20, yeah. And they are really good at that. Again, we're removing inspect. That goes away. And again, I'm just throwing arbitrary numbers out there. At some point, as an exercise, I might go to a coffee shop with some graph paper and really start to write out what all these things should be and how the world actually works. And I'm not an accomplished game maker. Oh. Ray Dathian points out that the to-do comment does sync with the task list. So I will upgrade that in my mind from maybe, and I don't know how much I trashed it just now, but if I made it sound awful, I will upgrade it from awful to style choice. And I hope I phrased it that way. Yeah. So yeah, whatever you're most disciplined at doing. So if you're using TFS and it's got, or if whatever PM tool or source control tool you're using allows for that to be a good practice, I'm all for it. I think maybe I don't have the discipline to really go back and diligently see those things. Okay. Thank you, Rajathian. We are all learning. I am learning. I did not know that about TFS. You're going to make me look really good at a meeting in the future when I go in. I give my little geek finger. I'm like, did you know? Trivia. Okay. Last one, Carpenter, I believe. Did you politician? Looks like it. Yeah, maybe Carpenter's got a hammer. And we're returning, or we're removing inspect. That goes away. He's pretty good at repairing things. And really don't take these numbers to mean much except for getting the bones of our interaction going. Okay. So we've applied our strategy pattern to all of our player classes. So now, whenever we call someone and have them do something, they're going to apply this algorithm based off of their class. And we've also set up the foundation for when we want to make these things a little more robust. We've got fuel for that. So we can start drawing on these statistics and start making some pretty complicated algorithms to decide the game mechanics. There's a good chance we won't need to do this for quite some time. Once we start playing the game, start performing actions and seeing the effect, we need to make adjustments. And it's not just this, but games are a great example of this because you can really start to empathize with, especially the massively online stuff where they're constantly doing balancing, they're constantly doing tweaks and adjustments, simply because things come together in ways with a sufficiently complex system that you couldn't have imagined. And you kind of get victimized for your success of good architecture because you create this world, and not just in this game, but just even in line of business software or anything that you're writing, you create this world with these rules, and it becomes like this living thing. And it'll do things that if you don't have a test set up, or if you don't have the understanding of the flow and the logic, it'll be smarter than you in some places, and you'll say, "Man, why did it do that?" And it's this very, very simple intelligence, but it is intelligence. And so we'll probably come back to this in a few weeks and say, man, okay, yeah, the carpenter feels like a person. It feels like it's making choices, and seemingly complex choices. So that's a really fun. I think if you're learning programming, that's definitely a fun part of it. Is kind of seeing these things become self-aware to a certain extent. All right, so we're getting to the end of our hour, but let's go back through and just take a look. Did some light refactoring, implemented some strategies that vary between our different classes. We didn't break anything, no breaking changes. Looks like we've implemented everything. So we're pretty close to being able to collapse this folder and focus someplace else. But before we do that, let's play around with the API and see what we've done. Alright, so I've got my factory, and I can create a new politician named Gary. I can create a new player named Beth. I can create new NPC types using my NPC factory. And I think behind the scenes, when no one was watching, I also created a monster factory to help me create a zombie. I can output whatever Gary's health is. I can have Morgan greet. I can display Morgan, who's an NPC, her type and hit points. And then I can have a zombie fight, which will return an amount of damage. And I'll apply that damage to Morgan. So one of the things that we haven't done yet either is state. So are you alive? Are you dead? Are you diseased? What's happening with your state? We haven't done that because that's another pattern. So to kind of keep things rolling, but also kind of keep us disciplined to really focus on what we're doing in the moment. I'll mention these things, but we won't dive into a lot of them. So I've got damage. I could also do this, right? So change to fight, but it could be attack. So Morgan takes damage from a zombie fighting. That's fair, right? We're splitting it up just to kind of walk through it and see it. And again, talking about the future. When we start getting into decorating, and we start getting into our command processing and doing these things, we will have these things nested in a lot of cases. All right, so Morgan takes that damage. We report back that Morgan takes damage. We output her name, type, and NPC or hit points. Then we have Beth heal. Okay, so here comes the first part of our algorithm where we can actually test something. So healing should return different values and also reduce the player's stamina by different amounts. So the first thing we want to double check is to see if we've given everybody a base amount of stamina. We might not have. So we create a new player. Well, let's come back over play factory. Oh, look at this. I have been a busy bee behind the scenes. Okay, so in our player factory, if you remember from our refactoring last time, instead of doing a switch statement on the type, we said, hey, one of the benefits of having abstraction and strategies is that we can have these game rules that any player can refer to. We don't have to instantiate new copies of these rules for every player. We can have the game engine be a little bit smarter and start to see how our implementations become more skeletal, and we start sharing and reusing as much as possible to keep the performance up, to keep the drag down, and to keep maintenance in the future pretty straightforward. So we've thrown in some, again, just playing around with some of the numbers. We said that hit points are 100 times your player health divided by 13.85. Meaningless numbers, but if you want to join me in the coffee shop with a piece of graph paper and we can start writing out a lot of these interactions, I think it's going to be kind of fun to start hammering out what this all really means. Okay, and so then we said dexterity, which we aren't really using yet, but it's to kind of play around with how numbers can come together and how this is our very simple algorithm. and this is a little more complicated. I think for me, and looking at design patterns implementations, it's good to always say to yourself, this is an algorithm. This, just returning 20, it's a computed decision. It's the simplest one possible, but it is a computed decision. So that when we then take the next step and we say, this is also a computed decision, this is also an algorithm. But the complexity of this algorithm doesn't cheapen this as an algorithm. Alright, so, and then we just say stamina is 20. Alright, so Morgan is an NPC, and we throw this in here as a reminder that NPCs and monsters and such, they have a place in the game. They aren't just this low res, wallflower. They should be able to interact. We should be able to communicate with them, to issue them commands, have them respond, and even if in our code here they're indistinguishable from other types, so you can't really tell is Morgan an NPC or a player, is a zombie a player, then we've done our job correctly, right? Then we have this level of consistency across our actors in the game that allows them to interact with each other in a way that feels real. That there doesn't seem like there's a second-class citizen. Okay, so let's see if this thing blows up. Control-Shift-B. Build succeeded. Doing things live is always interesting for that reason. Can't take a break and stare out a window when something goes wrong and then come back to it with a eureka. Or it's not eureka, right? That's interesting. It's the staring away for a second going, huh, that's interesting. Okay, so let's go ahead and just run this. Alright, so we outputted Gary's health just to show that we had a unique value for that. We outputted Morgan greeting just for giggles. We said that Morgan is a townsperson and she has 100 hit points. We had the zombie. He returns back 33 damage, which is not fun for Morgan. And Morgan takes damage. Let's go ahead and F10 down to the next line. And we're going to output how much damage she took. Morgan takes 33 damage. We output her current hit points. She now has 67 hit points. Beth. Let's look at Beth for a second. Before we get to, we're just going to read key here, so that's safe. Let's look at Beth. So if we dig in and looking at just how we got there, we're saying Beth is a player, and the base of that, we've got her stamina, right? These are going to be the things that she's inherited from our actor, our base actor, and then also if we go into the base of that, these are our game objects. So these are all the things we inherited from the base game object. Man, she's got a lot of hit points. That algorithm did wonderful things for her self-esteem. Dexterity, whatever that means, is destructible. False, should be true. So probably have to look at that. But 20 stamina. So what happens to her stamina when she heals? She's a medic, right? So, she heals. The stamina gets adjusted by 1 and return 20. And so again, we're inside the medic class, and that got associated with our player because inside of our factory, we said when you create a new player, point their strategy, their iPlayer strategy, at this map. And for the key of player type, this is going to be the behaviors we want to use. So pretty cool so far, right? So we're already seeing this abstraction paying dividends. So we can wire these things up in a way that just seems to work so far. All right, let's continue. All right, Beth moves to heal Morgan. All right, so let's go ahead and do a break line there. All right, so let's go back up to Beth. Player type is medic, we know all that. Boom. Stamina, 19. So, based off of our new kind of refined game mechanics, where something happened to Morgan as an NPC, Beth has 20 turns, essentially. We're not calling them turns since we can apply different algorithms to them and reduce the impact. But so she has 20 points of stamina, and she selflessly chooses to use 1 point to heal Morgan, an NPC. Very, very generous and noble of Beth. So if we start looking at what we wrote up earlier about the game mechanics, and if you're a medic, you can run around and heal many more people for much less stamina than an army vet could. And so we start talking about this game map where you have 20 zombies and 14 things need to be repaired and 13 arguments going on, and these things all require you and maybe a few other people to say, okay, we only have 20 points of stamina, who's going to handle what? Which definitely makes it easier if you've got a full team, but if you decided to play with you and a friend and it's a carpenter and a medic, you immediately have to start thinking to yourself, okay, which problems do we solve, and how do we do that in the most effective way possible, given our two classes? So that's the game. That is the essence of what we're going for as far as a fun, challenge-based, strategy-type, text-based game. All right, so that works. Let's move this around. All right, so Beth heals Morgan for 20 points because Beth is a medic and she rocks it. And I'll keep continuing here. Okay, now Gary moves to heal Morgan. Why would you do that, Gary? And then Gary, because he's not a very good healer because he's a politician, heals Morgan for 4 points of damage. Now, just to demonstrate, we have our politician, and if a politician goes to try to heal somebody, not only are they going to hurt that person, but they're going to use up 3 stamina points. We might make that a higher penalty, but don't really quite know. Let's go ahead and debug here. Okay, so let's go ahead and Gary for a second. Did Gary's algorithm apply itself properly? Yes. So by choosing to heal, he did damage to that person and also used 3 points of stamina from himself. So going back to this game world, you're saying, dude, you're a politician, don't waste your stamina healing people, repairing things, or fighting. Go settle all those disputes, and if you've got anything left over, then by all means come over and maybe you're a politician and I'm a carpenter, and neither of us is really good at fighting, or it's a higher cost. Let's go do the things we're really good at, and then we'll team up for the things we're bad at. And that becomes more of the strategy. So that's going to be the concept we'll be expanding out in this game brainstorming as a formal document. But we can already see it starting to come together in terms of the strategy pattern and the game mechanics. And when we start getting into the bridge pattern and the monsters and maybe even the NPCs, we're going to start to see how layered strategies in one domain affect the layered strategies in another domain, and how a fairly complicated system starts to arise out of not a whole lot of code. I mean, a lot of code in the tutorial or example sense, but as far as an application is concerned, we're just scratching the surface of how complicated things can get and how much architecture is required to keep all that very, very sane. Okay, so just to recap, we've got some good strategies going. We have refactored our game a bit so that it takes in this idea of turn-based stamina type actions. The things we have left to do in the immediacy are adding state to these characters so that every time you do something, it checks your state to see, okay, you just took damage, are you still alive? Or this thing just happened, well, how does that affect your status, right? You can see the strategy is getting a little more complicated. If you wanted to have anything of 10 stamina or below to induce a state of being tired, and maybe once you're tired, different classes incur that penalty in different ways, right? So there's all these fun ways we can incorporate different reasons and mechanisms for changing the strategies, and we're safe to do that because we've encapsulated all those strategies. We've abstracted all those strategies out away from the player, and they can all vary greatly and independently of one another. All right, I'm over my hour by a few minutes, but I think it's been good. Let me continue this. All right, so Morgan is a townsperson. She has 83 hit points. So she started off with 100. She got hit for 33 damage. She was healed for 20, and then she was healed for -4. The result is 83. Okay. Let me go ahead and check this in. We're committed to GitHub. And we'll say this: Saturday refactor. Alright, that's it for the Saturday refactoring. Let me sync this up. Next week we're going to go into the bridge pattern so that we can deep dive into our monsters and NPCs. Now that we've kind of closed or collapsed player and it's doing what we want and there's room there to grow. Pretty happy with that. NPCs looking pretty light by comparison. And monsters are also looking pretty light by comparison. Both implemented the factory pattern, but we haven't applied the strategy pattern to any of them because we want to use the strategy pattern in conjunction with the bridge pattern, which we'll learn on Tuesday. And I'll be clicking around, pretty much done for the day, but I'll let Twitch catch up. And then I'll close out in about 3 or 4 minutes.